So this video is brought to you by Lego Prince of Persia character. All right, so in the last video, you looked at taking condensed single logarithmic expressions and expanding them out into larger expressions using the properties of logarithms. We're going to do the same thing here, except we're going from the expanded side into a single simplified logarithm with a coefficient of 1. So what we're doing is going backwards from what you saw. Oh, I don't know that backwards is the right word. If you see addition, it turns into multiplication. If you see multiplication by a constant, it becomes an exponent. And if you see subtraction, it becomes division in that specific order. So here I see addition. So I'm going to rewrite this as log a of 75 times 2, which really simplifies to log a of 150. And we're done. That's it. It is now a single simplified logarithm. All right, so the next one I see subtraction. So that means the divisor is the thing that's being subtracted. So this becomes natural log of 54 divided by 6. Last I checked, isn't 9 times 6 or 54? So this would be natural log of 9. And then we could get an approximation of this. We could also get an approximation of this if we really wanted to, but at this point, we're happy with either of these two expressions. So this one now has both subtraction and multiplication by a constant. Well, let's take care of those constants first. Multiplication by a constant is the same thing as raising the thing inside the logarithm to that power. So really, we could rewrite this as log base a of x to the 2/5 and y to the 1/3. And now we can do the subtraction part, where that means we divide within a single logarithmic expression by the y to the 1/3. So this becomes log base a of x to the 2/5 divided by y to the 1/3. Now, we could write this in terms of radicals, and we could rationalize, but for now, I think I'm going to be happy with what we have here. Okay, this one, that's a little wild. So I'm going to take care of the things outside, the constants. So this would become natural log of x squared minus natural log of the square root of x squared. Turns out when you square a square root of x, that simplifies to just x. And so now we have natural log of x squared minus natural log of x. Well, because of the subtraction, we're going to divide by this within the logarithm. So this becomes x squared divided by x. Well, x squared divided by x is simply x. So the final answer is natural log of x. What a great problem, right? Okay, next one. We have to be careful. If you look at this, this is a 2 times x. We didn't fully expand this. We could have written this as natural log of 2 plus natural log of x. So one job has already been done for us. Now, what we could do with this parentheses, and probably what we should do, is rewrite this as natural log of x divided by y. You could also distribute the 3 through the parentheses and go from there, but I think this might actually be cleaner. Because now what we're going to do is take this constant and make it the exponent on this expression. In other words, we'd have natural log of 2x plus natural log of x divided by y cubed, which means we should apply the cube to the x and the cube to the y. Notice with the addition, we're going to multiply this piece times that piece. So we'll follow our same old patterns of how you multiply fractions. 2x over 1 times, now notice I'm going to apply the cubed to the numerator and the cubed to the denominator. So our last job is to simplify these exponential expressions inside here. This just becomes natural log of 2x to the 4th. We've got the same base, so add the exponents, divided by y cubed. Final answer. All right, next one. Boy, let's take care of the subtraction here, which means we're going to divide by this. So we're going to have to be careful with this one. I'm going to have log base a of a divided by the square root of x divided by the square root of a times x all over 1. Now that's a crazy expression. But remember, when you're dividing, So this is where a division sign is. That's the same as multiplying by the reciprocal of the divisor. So we could really simplify this to be log base a, leave the numerator the same, that's just a over x, and then turn it into multiplication. So 1 times the square root of a times x. All right, now we just have to multiply that mess together and see what falls out. Well, notice we have the square root of x times the square root of x. So this is going to become log base a of a over the square root of a times the square root of x squared. Now I did something a little wild there. I multiplied these two together and then pulled out the square root of a. What I'm applying there is the property that says the square root of a is equal to the square root of a times b is equal to the square root of a times the square root of b, provided they're not both negative, or one of them is negative and positive. So from here, we could rewrite this as log base a of a over the square root, well, we'll put the x out front, times the square root of a. Now, for this one, I am going to rationalize, unlike I did on the other one, because what falls out is kind of nice and neat. Well, actually, it's not nice and neat. When I rationalize, I would multiply by the square root of a, and what I get in the denominator is the log base a of a times x all over a times the square root of a, which, yes, that does fall out nice and neat. We end up with, oh, I'm out of space. Right. We end up with these a's canceling, and this is log base a of the square root of a divided by x. Final answer. Now, there may have been a better way to get to this, or another way to get to this that we certainly could have worked with. You might have noticed that up here, we could have split this and said this is log base a of minus log base a of the square root of x, and then we'd have 1 minus all this mess. I don't know if that'd be easier, but it might be worth playing with expanding this and then condensing. Okay, last two. They look really intimidating, but actually, this first one is not bad at all. See this subtraction? This just means that we're going to write log of x squared minus 5x minus 14 divided by x squared minus 4. And we're essentially done unless there's common factors between the top and bottom, because we have to perform these subtractions before we can do any sort of division. So if we can convert this into some sort of multiplication of something, then maybe we can cancel things between the top and the bottom. And so I note that the numerator factors to x minus 7 times x plus 2, and the denominator factors to x minus 2 times x plus 2, and oh, there is a common factor, so we get log of x minus 7 divided by x minus 2 is our final simplified answer. We should note that x cannot equal negative 2 in this expression. It can currently in this new simplified one, but from here it couldn't. So we would have to make sure that was an exclusion. If you recall from our rational functions, this would be a point discontinuity, not a vertical asymptote. All right, this one is a little bit more complicated because there's a lot of stuff going on in there. So I'm going to do our typical PEMDAS order of operations. I'm going to mess with the stuff inside the brackets. So I'm going to ignore the 2/3 for the moment. And I'm going to note that subtraction means division by what you're subtracting. So that bracket just becomes, shall I factor x squared minus 9? Yes, I shall. It just becomes this. We still have the 2/3. And then we're still going to have plus natural log of x plus y. Well, notice inside those brackets, because I factored x squared minus 9, this simplifies to just natural log of x minus 3. Again, note, x cannot equal negative 3 in this expression anywhere because it was excluded right here. Well, now I'm going to apply this thing as an exponent within the natural log. So we're going to have natural log of x minus 3 raised to the 2/3 plus natural log of x plus y. One last step to get a single logarithm with a coefficient of 1, and that is to note that addition is the same thing as multiplication of the two things within the radical. So this would just become x minus 3 to the 2/3 times x plus y, and it's natural log of all that. There you have it. That's our final answer. We could try to multiply this craziness out, but anytime you have those fractional exponents, that gets wild. So we'll call this good.